means distance from 0, which tells us what do we know is going to be our answer every time. It's always a positive number. We're counting how many steps, not which direction. How many jumps is it to that number from 0, not which direction are we going from 0. Once we add in that word direction, that's when we get our positives and negatives. Absolute value, we're just counting how far away is it. What's that distance? Okay, so if I look at that on a number line, I'll throw 0 in the middle and go 1, 2, 3, 4, 5. And as I go to the left, we're going to be -1, -2. I-5, yep. All right, so as we take a look at this, if I think of the absolute value of 4, how far away from 0 is 4? If I start at 0, it'd be 1, 2, 3, 4.
I said 4.
Yeah, I was just counting. Just took me a second. So absolute value of 4 is 4. Absolute value of -4 when I jump from 0 to -4, again, we're just counting jumps. So it's 1, 2, 3, 4. So absolute value of -4 is 4. Caesar, phone away. Zach, I got it. Thank you. All right, what if if I do 2 minus the absolute value of 3 minus 7? So this goes back to our order of operations, thinking about what we need to do first, second, third, all that good stuff. So what would I do first in this one? Good, we start with this absolute value. We do the 3 minus 7 is what? -4. Did I do absolute value yet? Nope, so we still want those absolute value signs. And then we saw that 2 minus in front. All right, and then what's our next step? Do we subtract or do absolute value? Good, we do the absolute value. What is the absolute value of -4? +4, so it's 2 minus 4. And what do we get for 2 minus 4? -2. So can an answer be negative that involves an absolute value? Yep, but that's with the stuff on the outside. What's the part that made it -2? Yeah, that 2 minus in the front is what made it negative. So as we work through today, just reminding ourselves it's okay to have a negative answer when there's lots of things, but when you do absolute value, we get positive. So we're going to start with the most basic equation here, which is y equals absolute value of x. So we're not going to do anything fancy with this. We're just taking the absolute value of the input and saying that's our output. So I'm taking my x and then my y. So let's start with 3. If I put 3 in, what's the absolute value of 3? 3. Perfect. What about 2? 2. Absolute value of 1? 1. Absolute value of 0. How far away from 0 is 0? 0. What about when I do negative 1? What's the absolute value of negative 1? Positive 1. Good. Let's just do negative 2 and negative 3. What would be the absolute value of negative 2? 2. And absolute value of negative 3? 3. All right, let's go ahead and you're going to glue in one graph, maybe a little bit higher, leave a couple lines underneath it. But next to this, or leave some on the side. That's what I'm going to do. Leave some on the side. So go ahead and glue in one of your graphs. You should have 3 graphs total. You're just gluing in one of them today. Right now. We're going to glue in the other 2 in a moment. Alright, so as we graph this, we're going to be using our x and our y. So first ordered pair is 3, 3. So from our origin, we're going to go right 3, up 3. So I'm going to zoom in here so you can see a little bit better. Sorry. So 3, 3. So right 3, up 3. Next we have 2, 2. So from our origin, right 2, up 2. Looks like it's going to be a line, doesn't it? 1, 1. So right 1, up 1. And then 0, 0. What do we call that point 0, 0? Origin. Good. It's right in the middle. So far it looks like a line, but then something special happens here. We get to our negatives. And it goes back up. So negative 1, positive 1. Negative 2, so left 2, and then up 2. And then negative 3, up 3. So what kind of shape do we get here? A V. Good. And I like that because it's absolute value. It's a little helpful to remember absolute value, V, value. We get a V. It looks a little bit like our shape from last chapter in Unit H. Does anyone remember what we called those U shapes? Parabola. Good. And those were U-shaped. This is similar. It's just a V shape. So we still have a vertex. Let's talk about our domain and range. That you guys did while I was gone for a couple days. So domain is our x's and our, as we go left and right. So I'm going to put D for domain. Does this graph, is it going to keep going to the right? Right, 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 right. Would that line keep going to the right?
Yeah.
Would it keep going all the way to the left? Yep, it's going to keep going on and on and on. So what do we say when it goes to all the numbers? Good, all real numbers. R is our range. Range is our y's. So it's if it goes up and down. If it was all real numbers, it would keep going up, 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 and it would go all the way down, down, down. So as I look at my graph, is this graph going to keep going up, 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 up?
Yeah.
Yep. Does this graph keep going down, 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 down? No, there's some numbers it will never get to. What's the number that that graph will never touch? Yeah, it never goes down to this -6. So what's the lowest that it goes? What's that lowest number it hits? 0, yeah. So I'm going to compare y and 0. And do I want the y's to be above 0 or below 0? Above. It keeps going up. So I'm going to use greater than or equal to. All right, so we got a couple of things to note about this. is so similar to our parabolas where we have a V, and there's that point where it hits and then it switches directions. Does anyone remember what do we call that point when it hits that point and then switches and goes back up? What do we call this point right at the bottom here? The vertex. Good. So here we have our vertex. And in this case, what kind of vertex is it? A minimum. It's all right. Just ask me to recall some information. So absolute value graph can also go the other V. It can kind of be an upside down V or like a mountain. And in that case, what kind of vertex do we have?
Maximum.
Good, a maximum. Still a vertex, but it's our maximum. Now that vertex, that spot where it turns around, if we think back to our number line, what number does it all originate from? Absolute value. Good. Absolute value is always our distance from 0. So we're always going to be looking for when does that absolute value equal 0. Okay, I'm going to use one highlighter today as we work. So if you want to grab a highlighter, that's going to be our biggest part that we're going to really need to know is when that absolute value equals 0. And that's going to be our vertex, whatever that is. Right, so if you want to make sure you grab a highlighter today, I'm going to keep using that anytime we do that vertex point. And then I have one last thing I'm going to write here, and then we're going to I'll flip to the next page because I'm running out of space. But when we have our equations, it always starts with y equals, and this is called the standard form. This is how absolute value functions look. It might change a little bit. The way the graph is shaped is always going to be a V. And we have A times, and then the absolute value. And inside the absolute value, I have x plus h, absolute value, and then a plus k at the end. Now that looks crazy. Yep, 100%, it's crazy. Okay, each of those little parts tells us something about that vertex. It tells us about that shape. The first number A tells us if it's going to be wider or narrow. Is it going to be a V that goes really, really wide? It makes a kind of more of a Y shape, a capital Y. Or is it a really, really narrow V? So wide or narrow. This year as ninth graders, we're not going to worry about that wide or narrow piece. In intermediate algebra, we're going to worry more about this H and this K. Okay, the H has to do with the X. It's grouped in with the X. So which directions does our X move? Right and X? Side to side, yeah, left and right. This one that's goofy is because it's in the absolute value signs, it's opposite of what we normally think of. So if H is positive, this graph is actually going to move left. If H is negative, it's actually going to move right. Okay, so that one's with the X. So when it's inside the absolute value with the X, that moves left and right. And it's opposite of what we normally think, which is a little silly. The K that's on the outside of the absolute value That's what tells us if it goes up or down. And this one's just normal. If it's positive, which direction normally is positive? Up. If K is negative, it's going to go down. Caesar, off your phone. Caesar. Okay. Okay. Alright, you guys are crushing this. I know these are kind of long notes today. It's because there's a lot of new information, but this is a lot of information we'll continue to do when we graph other things. We're going to be graphing square root functions, inverse functions, exponential functions, all the functions. It's going to be great. Alright, I'm going to flip my page because I'm out of space. So make sure you have this written down. I'm flipping my page. We're all good. Alright, we have 2 examples that we're going to go through today. So here's example number 1. Alright, our first example is f of x. Oh my gosh. Equals 2 times the absolute value of x plus 4. So our graph is always going to have an x and a y, but this time it doesn't have a y. What does it have? An f of x. Remember, that's just the function name. If I say look at function f, you guys are like, oh yeah, that's function f. We got it. Okay. What do we know about this graph? Is it going to go up, down, left, or right 4?
Up.
Is this one of the,
Positive, so up.
is it the h or the k though? It's the h because it's inside the absolute value.
So up.
So is it going to go left or right? K tells us up and down. That's outside.
Left.
It's positive, so it's going to go to the left. So it goes left 4.
So there's no H.
No h this time. Nope. Just that k. So that's just for something for us to check our work with. We want to make sure as we look, it's going to look like that v moved to the left 4. Yeah. Sorry. I got to sign in. It's been a struggle. Okay. So as we start this, the first thing we need to do is find the vertex. And the vertex is always when the absolute value equals 0. So I'm going to think absolute value. And I'm only thinking what's inside that absolute value. So what's inside my absolute value here?
X plus 4.
Good. X plus 4. All right, now as we solve that, we're really just thinking what plus 4 is 0. Some of us can do that in our heads without having to think too hard. Some of us need to write that out, and that's okay. So we have x plus 4 equals 0. And my goal is to solve that. So if I was going to get x by itself, how would I undo adding 4? Good, subtract 4. So x equals negative 4. All right, after we find the vertex, the next step is to make a table. When we make a table, normally we have an x and a y. Today we'll have an x. And then instead of y, we're going to use f of x, saying what is our output when you put it into f. So we have our input, and then what's our output after we put it into this function. Now we found our vertex is going to happen at negative 4. So when we find a vertex, do we want that to be at the beginning of a table, the middle of the table, or the end of the table? Middle, good. So I'm going to throw negative 4 in the middle. And what's going to go above negative 4?
Negative 3.
Sure, negative 3, and then negative 2. And then after negative 4 would be negative 5 and negative 6. If you had it the other way, if you did negative 5, negative 6 above, is that okay? Yep. All right, at this point, we use our decimals calculator. You can do it by hand as well if you'd like to. You can think negative 2 plus 4 absolute value times 2. You can't see what I just pointed out, this function here. So if you want to write this, this might be helpful for this part here. What we're doing is we're doing 2 absolute value. And then does anyone remember when we did that with parabolas, what do we use instead of x? Parentheses, yep, plus 4. Absolute value. So that's what we're doing to find those answers.
So we put the answers
In this column, yep. So in Desmos here, I'm going to do 2. Absolute value is this A button right here. Whoops, that's pi. This button right here. Absolute value. I'm going to do parentheses plus 4 absolute value. And then instead of the parentheses, what number should I put in first? Negative 2. Put in negative 2, and we get out positive 4. I'm going to delete negative 2, put in negative 3, we get out 2. Delete negative 3, put in negative 4, we get 0. Now what should happen when I put in negative 5? Remember when it hits that vertex, what should happen next? Yeah, it should go back, it should repeat. So it should be 2. And when I put in negative 6, what should I get? 4. Yep. And that's a good way for us to check to see if we did it right. All right, glue in another graph. I tried making them small so I don't take up too much space. I might have made them too small. Whoops. Did I make them too small? What's our opinions on these graphs? They're okay. I feel like a little bit bigger would have been okay. Can you see the numbers? I can, I guess. They're not that small. I'm not that old. Alright, so as we look at those points, we're plotting those points. We have negative 2, 4. So from our origin, how are we going to go to negative 2, 4? Two left, and then up 4. You got it. Negative 3, 2.
right 3. No, left 3 up 2.
Left 3, up 2. Good. Zach, you got that up 2 part. All right, what about negative 4, 0?
The same.
Negative 4
Up or down or left or right?
Just put it on negative 4.
Yeah, good. On our x-axis, negative 4. That's going to be your biggest part. Most people need to get this part. They put it down here on the y. Remember, it needs to go on the x. All right, negative 5, 2. And negative 6, positive 4. Did we get that nice V shape?
Yeah.
Good. That's our goal. All right, for our domain is left and right. Will this graph keep going left, 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 and right, right, right? Yep, so all real numbers. When Miss Morrell gets a little lazy, I just write all reals. Good enough. You know what it means. All right, for our range, though, range is up and down. Does this graph go all the way up and all the way down forever and ever and ever? It keeps going up and up and up and up forever and ever. But what's the lowest points it hits on the way down? -4 is our x. Remember, we're looking at our y. 0. Good. So we're going to have y and 0. Are the y's, is the graph above that 0 or below that 0? Where's our lines? They're above, so greater than or equal to. This time it can be equal to 0 because it's touching that 0. All right, you guys got this. You're doing so good. I know, it's long notes today. It's the longest ones of the week. All right, number 2. Last one. Number 2, we have h of x equals -3 absolute value of x minus 3 and then plus 4. You guys are crushing this. I know these are long notes. Amazing. You guys are so good. All right. So, first off, let's take a look at this based on our pattern. Which directions is this going to be moving? Is it going to be moving left or right? As we look at our h, that's our left and right. Do we have a positive or a negative? Positive. Minus, right? So negative, so it's going to be going right. So it's a -3 here. So,
what letter are we looking at? H?
that one, yeah, H. All right, so that first number tells us that we're going to be going to the right 3. And what does this 4 tell us? What? That would be if it was in the absolute value. Then it would tell us left. This plus 4, since it's outside the absolute value, it'll be up. Yep. All right, first step we're going to do is find our vertex. All we need to do for the vertex is figure out when does that absolute value equal 0. That's what we're thinking first, is absolute value equals 0. And then I'm going to fill in that absolute value. What's in the absolute value? X minus 3. Good. And some of us can do that easy peasy without using, without writing a solving equation. We can just think what minus 3 is 0. What do you guys get? What minus 3 is 0? 3 minus 3 is 0. If you're not sure, that's okay. Write an equation. Sometimes we have a tough time with math, even though we know the answer to that question. When we're like asking it as a vertex, our brain is like, what? Okay, how do we get rid of a minus 3? Plus 3. And 0 plus 3? 3. All right, so that's our vertex. So our next step is to make a table. And when we make our table, where's that vertex going to go? In the middle. Good. So I have x and h of x. And 3 is going to go in the middle of that table. So it goes above 3. Sure, 2 and then 1. What would come below 3 then? 4 and 5. Beautiful. This time we're going back to that equation. Because this is our notes, if you need to write this part, that we do -3, absolute value, and then parenthesis, minus 3, absolute value, plus 4. If If you need to write down that rule, because you're going to get some numbers here, and you're going to be like, where the heck did we get those? And if you want to write like Desmos next to it, to remind yourself, hey, we used Desmos in this part. However that makes sense to you, so that when you look back at your notes for your test next week on Thursday, you'll be like, oh yeah, right, we used our calculator.
Can we use it on
The calculator? Yeah. I wouldn't take this test without a calculator. It's a lot of work. Alright, so we get -3. Again, absolute value, it's right up here with this A with those straight lines. I'm going to do parentheses, -3, absolute value plus 4. Okay, and big thing here is that seeing that symmetry, how it's going to line up, is going to be a good way to check our work, see if we're doing it right. First number we're going to put in is 1. We get out -2. Delete the 1, put in 2, we get out 1. Delete the 2, put in 3, we get out 4. And then this is the part where we can start checking our work. When I put in 4, what should we hopefully get out? 1. Woo! Did it right. And instead of 4, put in 5, and we get -2. Alright, glue in that last graph if you haven't done so already. I noticed a couple of you worked ahead and glued that in that space. Last graph. Did you lose it? Okay. Alright, if you want to start, if you got that glued in and you want to start plotting those points, go ahead and work ahead. We're going to plot those points, find our domain and range, and then we'll be done. Big notes today, I know, it's crazy. Crazy. Alright, so for our first number here, we have 1, -2. So from our origin, we're going to go right 1, down 2, two, 1, so right 2, up 1, 3, 4, so right 3, up 4, 4, 1, so right 4, up 1, and 5, -2, so right 5, down 2. This time, does this absolute value have a minimum or a maximum? Good, maximum. So let's real quick identify that domain and range. Yeah. 1, -2, it's right here. Right, 1, down 2. Good. What did you get for domain? All reals. Good. Does it keep going left and keep going right? Yep. That's what those arrows mean. Good. It keeps going out, 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 out as it goes. All right. What about range? Does it keep going up this time?
Yeah.
It's going up, 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 up.
Oh no,
It keeps going down. So I want to say, what's that highest number that my y's get to?
4.
The y's hit that 4. Once we hit 4, it goes back down. So I'm going to use y and 4. And then for my greater than or less than here, I want to think, is my graph below the 4 or above the 4? It's below the 4. We're going down. So is that greater than or less than? Good, less than. And can it equal 4? Yep, we hit a 4. Nice. Woo! That was a long set of notes, guys. You guys crushed that. There is a quick check today. However,